Welcome back to Chemistry and Physics on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to do a sample Dixon-Q test. So we've got 5 pieces of data right here. We've got basically 5 temperatures. We've got 57.6 degrees Celsius, 69.6, 68.6, 68.3, and 69.1 degrees Celsius. And in a Dixon-Q test, we're going to be looking for one of these points that we want to determine whether or not we can discard it because it's an outlier. And in this problem, this is going to be our clear potential outlier. All the other 4 numbers are going to cluster around roughly 69 and so forth, 68, 69. But this one's all the way down at 57.6. So we're going to see whether or not we can throw this point out, and that's going to be done through a Dixon-Q test. So the first thing we need to do is calculate the variance. So the variance is literally just going to be the absolute value of the difference between this number right here, which is our outlier, and the number that's directly next to it when we put them in numerical order. So obviously 57.6 is our lowest number. If we look for the next lowest number, that would actually be 68.3. So one key with the Dixon-Q test is you have to first put the numbers in order. But clearly if we number them, this is our lowest, then we have 68.3, we then have 68.6, 69.1, and then 69.6. Okay? So the variance would just be the difference between the one that we're trying to throw out, 57.6, minus the next one in the sequence, which in this case would be 68.3. So it's always the number directly next to it once you put them in numerical order. So now let's go ahead and take this difference, and notice that it's the absolute value, so I'm just going to take the positive of it. So I can do 68.3 minus 57.6. All right, and the number that I get out of this is my variance, and that is 10.7, okay? And I would have to include the unit in there, okay? So that is my number, and it has the appropriate number of significant digits, all right? Now the next thing I have to do is calculate the range. So with the range, I'm going to take the highest number in the sequence, which is my 69.6, and subtract the lowest number, which is actually the number I'm trying to throw out, 57.6. So that would be 69.6 degrees Celsius minus 57.6 degrees Celsius. Let's plug this in. I get 69.6 minus 57.6, okay? And this is going to give me 12.0. Remember that I have to keep the number of numbers after the decimal point consistent when I'm doing subtraction. So this one has one number after the decimal point. This one also has one number, so my final answer will also need one number. And so my range, when I put the appropriate units, is going to be 12.0 degrees Celsius. Okay? Now, in order to calculate the experimental Q value, so if I want to calculate Q experimental, what I need to do is I need to take, let me move this out of the way for a minute, the quotient of the variance and the range, okay? So that means I'm going to take this 10.7 degrees Celsius and then divide it by the range, which is 12.0 degrees Celsius. And let's see what that comes out to be. So this is going to be 10.7 divided by 12.0, and I get a decimal. So my Q experimental in this case is going to be 0.892 when I round it to 3 significant digits. 0.892. And again, the reason I'm rounding it to 3 significant digits is because I've got a quotient here. Okay, this number right here, the numerator, has 3 significant digits. The denominator here also has 3 significant digits, so my final experimental Q will have 3 significant digits. Now the test to determine whether or not you can throw out this data point right here is if your Q experimental is greater than your critical Q, okay? If this is the case, then you discard the point, okay? However, if it were the reverse, if Q experimental were less than the critical Q, then we would have to be forced to keep the point. And in this case, our critical Q, which is given to us in the problem, our critical Q is 0.642. And this is the critical Q when we have 5 data points, okay? We could look this up in the table. However, in the problem it's given to us because we have 5 data points. And in this case, we compare them. Our Q experimental, which is 0.892, is in fact greater than 0.642. So because this is true, then we actually are going to discard this point. And so then our data would only consist of these 4 data points right here. Okay? So this is an example of a Dixon-Q test, the kind of which you'd be responsible for working on the skills test. Okay? So make sure you can do this. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you very much.